There you go, Kyle. It's all yours.
All right. Thank you, Jennifer. Welcome everyone to Supercompute 21. My name is Kyle Harper. I am Director of AI Strategy for the Precision Workstation product line here at Dell Technologies. And it is my pleasure to be talking with you today. Hope the rest of your sessions that you're attending here at Supercompute are turning out to be exciting. You are in the right session if you're here to see what the next big thing is in AI, specifically as it pertains to workstations. We're going to be walking through AI and data science workloads on workstations that literally demonstrates that it's not just hype that's in advance. These are real solutions that are available today that I'm going to be walking you through and describing these demonstrations. And these are solving real problems that are hard problems that only supercompute platforms can do across multiple industries. And so with that, let me go ahead and get started. Now, we develop solutions here at Dell Technologies for artificial intelligence and data science. Of course, we do not do this alone. We develop our solutions with partners, ISVs, and other partners that are developing specific solutions for different industries. We show a few of the logos of some of the strategic partners we have across all the different industries and market segments. In addition to all of the partners that we do work with, we also have even closer relationships with quite a few of them, and they are part of our strategic partnerships. And I am going to be walking through some of the some demonstrations of some of the solutions that we have with our strategic partners in the time that we have here today. So welcome, and let's get started. The first one that I wanted to walk through is a solution that is called Surgical AR. And this is from a strategic partner of ours that we've been working with for quite some time, well over a year with, a company called MetaViz. And these guys envision nothing less than the OR, or the operating room of the future, and making that happen as a reality today. And the OR of the future that they envisioned was literally a fusion of data that literally allows them to be able to, as the surgical team is getting ready to start a procedure on a patient, they're literally able to use artificial intelligence, deep learning artificial intelligence specifically, combined with AR, VR, or augmented reality, so that they literally can overlay a patient's data literally on top of the visual, the video that's coming in from right there in the operating room right before they go into the procedure. And you can see how they're able to manipulate the data literally in a much more logical way. And you can imagine, since this is a supercompute conference, you can imagine the massive amounts of data that is being literally manipulated in order for this overlay of augmented reality to happen in real time, right before a surgical team is about to open up a patient and do surgery. Now, why is this important? If you talk to any surgeon and any surgical team that is going in to their procedures, their highest risk is any surprises that occur once they start a procedure. So if there is any user-friendly and surgeon-friendly system out there and tools they can use to literally identify any surprises, walk through it in a simulation, and walk through the procedure before they open up, that eliminates all but a very, very, very tiny portion of risks that might be associated once they open up that surgery. And so that's why you see what these guys are doing. And this is a major breakthrough of being able to use augmented reality so that they can literally look at a patient's data, and have it presented to them as if it literally is overlaid on top of the actual visual that they're looking at in real time. Very, very impressive. And this is available today, and it's working on workstations that are right in that OR room or in literally the support room right next door, and using their AR, VR glasses. So that's from MetaViz. A second partner that we work with for quite some time is a company called Paravision. Paravision is one of the leading companies worldwide in face recognition and object recognition. one of the things that makes them industry leading among lots of solutions out there that do face recognition is they're able to do it in real time and in very, very difficult real world situations, not in a controlled environment where it's easier to recognize, a face that's being recognized against a database, but in very difficult and challenging environments. And we're going to go through a couple of demonstrations of that. Let me set this first one up here. I'm going to play a quick video here that literally is an elevator lobby in an office space, anywhere in the world. And through a video feed, a 1080p video feed that is coming in at 15 frames per second in this case, from a commodity IP camera. This is a camera that you and I could go buy on Amazon and set up. So it's nothing special there. It is 1080p. And what you're about to see is matching face recognition of individuals, employees that are coming through this space randomly. And whether they're looking into the camera directly or whether they're just glancing across the field of vision of the camera, you're going to see the faces get recognized in real time with extremely high quality. So let me go ahead and roll this tape. And as you're looking at this, the image, the video is being that is streaming off of this camera is being compared against a 14,000 person employee database across very broad demographics, all shapes, colors, sizes of people. And take a look at those confidence ratings of recognizing each one of those individuals that are coming across and entering into the workspace right there. Let me run that through again and walk through a little bit. They come in, they're not even looking at the camera. You see where the faces are recognized and the confidence level of each one of those. And regardless of whether they're looking right into the camera or not, those confidence ratings are up above 95 percentile, and in most cases, 99.9 something percent accuracy on that. So, and it's all happening in real time. This is not post-processing. And that's what really takes the compute horsepower that we're demonstrating here. The next example of Paravision's technology is performance with and without face masks. Because of the pandemic, there's been an emphasis on being able to recognize employees, or literally just recognizing if people are wearing face masks or not, just for statistics and seeing, hey, what kind of metrics can we have out there that indicates what percentage of people are wearing masks, perhaps at conferences like Supercompute and things like that. So here's an example of their face recognition, which you saw an example of just a moment ago, being applied here. It's their standard Paravision face recognition model. And on top of that, they developed another AI model, deep learning model, that literally recognizes whether a mask has been detected on this person or not. And so this first video over here on the left is Tiffany, who happens to be Paravision's financial controller. And she is being used as a guinea pig, and shows you what the recognition is there. It immediately recognized Tiffany, whether she's looking straight at the camera, up, down, or sideways at an angle. And it recognizes her immediately in real time. And then she dons the mask, and it detects that, yes, this is Tiffany, and she is wearing a mask. Now, it's one thing to be able to do that, with a single individual in a relatively controlled environment like we're seeing in this video. But that those same two deep learning inference models applied in a more public space. I wanted to show this video over here on the right that shows the same technology, the same solution being used in a commuter corridor. And the purpose it was being used for here was literally recognizing how many people that come down this corridor are wearing facial masks and those that are not, as a percentage, so that they can kind of gather some statistics on what's happening. So out in public, and there are literally hundreds of people coming through this commuter corridor, every minute. And the thing to look at here is the green squares recognizes people recognizing those individuals that are wearing masks. It's recognizing the fact that they've got their masks on. The red squares are the ones that are not donning masks. The thing to look at here is look how far deep into the visual frame it's able to do its detection and mask whether the mask is on or not. that takes high amount of high compute horsepower and a very sophisticated deep learning algorithm to be able to do this many and with this depth of field of vision, if you will, on that. Really impressive technology that they do have. And let me move on to the next demonstration. Now, the final demonstration of Paravision's solution for face recognition is physical access control. In this case, it's people that are driving through to go into the parking lot as they're coming in to work. Before facial recognition like this, these people would have had to have stopped, rolled down the window, taken their badge and put it on a little detector pedestal, and that slows things down. So imagine if you're in an urban environment like in downtown Tokyo or Shanghai, you know, or somewhere in Seattle or something like that, and you're backing up traffic whenever you've got people stopping, badging in and going through, you're backing up people out into the street and things like that. Frictionless access control is the objective here. The demonstration that you're about to see here is literally going to show you where employees are being recognized, you know, by a video camera, a deep learning algorithm that is able to recognize the individual behind the glass of the car moving at 10 miles per hour and recognize multiple people in the car that are going through and be able to do that in real time at 10 miles per hour. And in this case, it's comparing that image, the person in that image, and matching that against a 13,000 person employee database. Now, the first time through on this video, you're going to see at 1/10 real-time speed, and that's so you can actually see what it's doing in slow motion, and then it'll run through the same thing at full 10 miles per hour. And I think you'll get an idea about how impressive this technology is, especially through the glare. So here we go. Car is going through at 10 miles per hour. This is in slow motion. Look at the glare on the glass. The gentleman happens to be wearing glasses, and it gets recognized immediately. And then it does the same thing with the person in the back and matches those two employees to come through. And this is at full time. Let me do that again. First time, slow motion. That's impressive enough at 1 mile per hour if you think about it. And then at full speed, I can't even recognize the person, you know, behind the glass to know who it is. Happening in real time. Hats off to Paravision. Now, we work with another company called Digital Harmonic, and they have produced a solution called Pure Pixel that literally takes a video image that's coming in at 1080p or 720p or whatever from commodity cameras that are in drones or in public cameras, and it takes that and denoises whatever that video is. In this case, the demonstration I'm showing here literally shows the before and after. The algorithm cleans up an image and denoises it, whether it's from fog or smog or particulates or humidity or smoke or anything like that. Broad applications across multiple industries. So on the left, you see the unprocessed video, and you can see the car going through a very dusty road rally environment. On the right, you see how it's been denoised, and you can actually see the cleaned up image. Now, it's not Hollywood special effects quality image, but literally it's clearing that up so you can actually see much more in that image than just the car going around and kicking up dust. Now, that's interesting enough, but the question is okay, now that we've got cleaned up data, how many more objects can we detect in that image after it's been cleaned up by deep learning? These are two applications, algorithms working in concert with each other. There is the deep learning algorithm that is denoising in real time the video image, and then there is a deep learning model behind that that is doing the object recognition. Now, the object recognition is what creates the squares in the videos that you're about to see, of course. Look how many more objects are being recognized on the processed image to the right than what it's the object recognition algorithm detects on the left. Of course, it sees the car. That's obvious. Well, look at the objects back in the distance that you can see now that the signal has been denoised, or the video has been denoised. Impressive. Now, the other one that I wanted to show you that really brings home why this could be life-saving is, this this demonstration right here. On the left is the raw video feed from a camera on a building that's looking down over what appears to be a street intersection. And on the unprocessed image, you can see some traffic lights, and you can see what appears to be a traffic intersection. And you happen to see the headlights first, and you can kind of make out the car that's going through that intersection. On the right, look how much more it's cleaned up. You can see the sidewalks. You can see all the lanes of traffic. You see the car coming across. But only in the cleaned up image do you see the pedestrian walking across the crosswalk at the intersection. Now, if you knew what you were looking for in advance, you could actually see that gentleman walking across that crosswalk over in the unprocessed image. But look how much more clear it is, and you can see people that perhaps are in harm's way crossing across the street on a foggy morning. So these are all demonstrations of what denoising a video image in real time, what solutions and what problems it can solve. Now, in the case of Pure Pixel, I'll use them as an example right here from Digital Harmonic. What is the compute horsepower, that you need in order for this real-time image processing to be done? Now, in the case of Pure Pixel, these demonstrations I just showed you, it doesn't take anything more than, in this case, a Dell Precision 17-inch data science workstation laptop, a 7750, that has an NVIDIA RTX GPU card in it, an RTX 5000, and it is able to do this real-time processing. The inference engine that is running in that laptop can keep up with 2 independent feeds of 1080p at 30 frames per second. And if you move up to a 7920 data science workstation tower with the RTX 8000 GPUs, or even better with the A6000 that is out now, you are able to process upwards of 10 of those 1080 30 frame per second video feeds. And if you needed or could drop back to standard definition video feeds, that independent number of feeds jumps to over 25. And this is happening in real time, meaning that from the time that raw video goes into the algorithm till the time it is displayed on the monitor is only 15 milliseconds. And so it is real time. These solutions from Digital Harmonic and from MetaViz and Paravision, they also can run on servers in the data center as well. So these are algorithms that are trained and also deployed on workstations and on data center servers, and can be deployed on either workstations or data center servers. So when you're a developer of these algorithms, you have a myriad of solutions for first training your models, using deep learning and machine learning algorithms, and what you would from the Dell Technologies portfolio, the platforms that we would suggest that you use when you're developing as a data scientist these models. Use the data science workstation product line workstations to do the development of that model. And that come in rack form factor, or those mobiles that we're talking about, and the fixed workstations all the way up to 7920 tower. Once you've perfected your model and you're ready to deploy it as an inference model to all of your users out there, then of course those can run on those same type of models, compute platforms that I was mentioning. But the rest of the AI-ready workstations that are available from Dell Technologies as well. Some examples that we're showing here is a 3930 rack, or that same 5760 mobile that you can use for training, or literally in a small compact workstation form factor, you can take these inference engines and run them and see that kind of performance that you just saw on something as compact and cost effective as a 3240 compact tower that's not much taller than a couple of coffee cups stacked on top of each other, with an RTX 3000 or 4000 GPU card in them. So whether you're developing or deploying, you've got solutions here. And the message I wanted to leave you guys with at Supercompute is that there literally is supercompute workstations and compute platforms that you literally can fold up and slip into your backpack today. They weren't even available 5 years ago. And that's where supercompute is going. What used to take mainframes, mini computers, data center servers, in years past, that now is you can put in your backpack and you can take it to where your data is being created that you need to do your data science on. So that's what I had for you today. If you wanted more information about Dell Technologies or from NVIDIA, our partner for the GPU acceleration of AI, or any information about some of the partners that I highlighted today, Paravision, Digital Harmonic, or MetaViz, here's where you can go for more information. To close out, I just wanted to thank you guys for joining the session here today. I hope it was inspiring and shed light on solutions that are available today. It's not hype, it's real out there. And that these data science workstations are developed and validated by companies like NVIDIA and Dell and Canonical, the people that bring you Ubuntu operating system, which is the platform that the operating system that all AI on workstations still continues to be developed on. These workstations that we validate are literally for people whose work is really important and the time is highly valued by everybody around them. You guys are the innovators of the organizations that you're doing your work for. So just keep on doing what you do, be your brilliant self, and let us know if there's something that we can do to provide you with better compute platforms that can get you through your innovation and your learning cycles and training cycles on these data science models that you're doing. And with that, thank you and good luck with the rest of your time here at Supercompute 21.